Welcome to Rate Laws, Predicting the Reaction Rate. In this section, you will need your calculator, pen, pencil, and paper to ask questions, write questions down rather. If the questions are not answered as I go through this section, please make sure that you post your question on your teacher's office hours discussion board. That way, others will be able to see your question, and they will also benefit from the answer that your teacher has given you. We are creating that community so that others will know that if they have a question about content or about application, they can check the discussion board first to see if maybe that question has already been posted and has been answered, or they can post their question and everyone can benefit from the answer that your teacher gives you. So let's get ourselves started. When we change reaction rates, we can determine what's going to happen because we multiply the individual effects of the reactants being changed on the rate of the reaction. Let's look at this again a little bit closely. We can figure out what will happen to a reaction if we change the reactants or change their concentration. How do we do this? We multiply their individual effect on the rate of the reaction. For example, if I have this rate law is equal to K, A concentration to the X power order, B concentration to the Y power order, then in order to find out what happens if A is doubled and B is tripled, we put what's happened to your reaction here, and then whatever their order is, it's to that power. So if you double A, then it's going to be 2 to whatever order A is. If A's order is 0, then it will be 2 to 0, which is equal to 1. We know nothing happens to the reaction rate, right? Okay. If we triple B and we say, okay, we're going to take 3 to the third power, if that's the order of B, then we know that 3 to the third power should influence your reaction rate by 27 times. So if I want to know what's going to happen to the rate of the reaction because I double A, I triple B, then it's going to be 2 to the 0 times 3 to the 3, which is going to be equal to what happens to the rate of reaction. Well, we know 2 to the 0 is 1, and we know 3 to the third is 27, so that is 1 times 27, which is going to be equal to 27. So the reaction rate increases 27 times faster. Let us begin. Here's your rate, law rate. What effect will there be on the reaction rate if A and B are doubled? So we're going to take A, reactant A. We're going to look at reactant B. We are not going to look at reactant C because we're leaving C as constant. If this was a table, C would be constant on the table. So we take doubling of A. Make sure I've got this correct. There we go. There we go. Love technology when it works. All right. So we have doubling of A. We have doubling of B. We know A is to the second power. B is to the first power. 2 to the second power is equal to 4. 2 to the first power is equal to 2. And 4 times 2 is equal to 8. It is just that simple. I know you're looking for it to be harder, but it is just that simple. Once you've done the work and you've created your rate law, you can answer these questions very easily. So let's do some more. What effect will there be on the reaction rate if A is doubled and C is doubled? Pause the video, do the problem, and come back and check and see if you've got this. Did you take 2 to the second power for A, which is here, and 2 to the third power for C, which is here? Multiply them together. You actually have 4 times 8, which gives you 32. If that's the answer you got, you're doing great. If that's not the answer and you were unable to get that, pause the video and write wherever it is that you got tied up or that you didn't understand. What effect will there be on the reaction rate if B is tripled and C is doubled? Well, this time we're working with B and we're working with C. Pause the video. See if you can answer the question. Come back and check. Press play. Well, you should have got 3 to the first power times 2 to the third power, which is 3 times 8, which is 24. Given the rate law, K, A to the second, B to the first, C to the second, what happens to the rate if reactant A and B are doubled? Once again, we are not looking at C, so don't use C as you go through the parameter. See if you can't solve that. Come back and press play when you're ready to check. Reactant A squared is 4. B to the first power is 2. 4 times 2 is equal to 8. So the reaction is 8 times faster. Again, pause the video. If you're not quite sure, make sure you understand what we're doing. Write the question down. Press play when you're ready to move on. What happens to the rate of the reaction if reactant A and C are doubled? In this one, we're not going to look at B at all. Do the reaction, do the problem, pause, and then press play when you're ready to check. Reactant A is 2 to the second power, which is 4. Reactant C is 2 to the third power, which is 8. And 4 times 8 is 32 times faster. What happens to the rate of the reaction if reactant B and C are doubled? Again, pause the video, see if you can do the problem, come back and check your answers. Reactant B is 2 to the first power, which is 2. Reactant C is 2 to the third power, which is 8. And 2 times 8 is 16 times faster. Your turn. Given the rate law, you see right here, what happens to the rate of the reaction if reactant B and C are doubled? Pause the video. Come back and press play when you're ready to check the answer. The answer for this, reactant B is 2 to the 0, which is 1. And C is 2 to the second, which is 4. And 1 times 4 is 4 times faster. Given this rate law, what happens to the rate of the reaction if hydroxide ion is doubled or OH negative is doubled? Pause the video, solve the problem, press play when you're ready to check your answer. Reactant of hydroxide ion is 2 to the fourth power, which is equal to 16. We're not mentioning anything about the hydrogen ion. We're just looking at the hydroxide ion. Okay. This ends predicting the rate of a reaction.